Now we will discuss data frame as a two-dimensional array. This topic will be the focus for this lecture. As mentioned previously, we can also view the data frame as an enhanced two-dimensional array. We can examine the raw underlying data array using the values attribute. Now, with this picture in mind, we can do many familiar array-like observations on the data frame itself. For example, we can transpose the full data frame to swap rows and columns. Now, when it comes to, we got the output this. So now when it comes to the indexing of data frame objects, however, it is clear that the dictionary style indexing of columns precludes our ability to simply treat it as a NumPy array. So in particular, passing a single index to an array accesses a row. And passing a single index to a data frame accesses a column. Now, data Thus, for array style indexing, we need another convention. Here, Pandas again uses the LOC, log, ILOC, and IX indexers mentioned earlier. Using the ILOC indexer, we can index the underlying array as if it is a simple NumPy array, using the implicit Python style index. But the data frame index and column labels are maintained in the result. I'll show you here. Now, I will write for data LOC Illinois. Make sure the spellings are correct. ILLINOIS. Wow. We got the result this. The IX indexer allows a hybrid of these two approaches. Data.ix. Pop. We got this error, I guess. Okay, so no, we just got the documentation. The result is this. Result is this. So keep in mind that for integer indices, the ix integer is subject to the same potential sources of confusion as discussed for integer index series objects. Any of the familiar NumPy style data access patterns can be used within these indexers. For example, in the LOC indexer, we can combine masking and fancy indexing as in the following. I'm going to show you. Any of these indexing conventions may also be used to treat or modify values. This is done in the standard way that you might be accustomed to from working with the NumPy. Data.il deleting. Make a file here. Data.iloc 2 equals to 90. Data. We got the result this. So to build up the fluency in Pandas data manipulation, I suggest spending some time with a simple data frame and exploring the types of indexing, slicing, masking, and fancy indexing that are allowed by these various indexing approaches. So now let's discuss additional indexing conventions. So there are a couple of extra indexing conventions that might seem at odds with the preceding discussion, but nevertheless can be very useful in practice. First, while indexing refers to columns, slicing refers to rows. Florida got the result. This such slices can also refer to rows by number rather than by index. Similarly, direct masking operations can also interpret it row-wise rather than column-wise. These two conventions are syntactically similar to those on a NumPy array, and while these may not precisely fit the mold of the Pandas conventions, they are nevertheless quite useful in practice.